All right, guys, welcome back. And today we are looking at lesson 1.5, creating scatterplots. So let's get cooking. So last time we looked at two-way tables, and two-way tables were a good way to show two categorical variables. Today we're going to talk about scatterplots, which we're going to use to display two quantitative variables. So over here, I gathered some data about population density of different states and their COVID deaths per 100,000 people. So what we're going to do here is we're going to determine if one we think explains the other. And the reason we're going to do this is conventionally we want to put, when we have a scatter plot, if we think one variable helps to explain the other, we would want to put the explanatory variable on the x-axis and the response variable on the y-axis. This is kind of like the independent and dependent variable that you learn about in science. So in this case, I gathered this data because COVID transmits when people are very close together. So population density could be something that could help to partially explain the COVID deaths per 100,000 people. So what we're going to do is we're going to make population density our X variable. And one important thing to note when we're making scatter plots is make sure that we label our axes. So this is population density. And we're also going to include the units. This is people per square mile. So this population density tells me on average how many people are there per square mile in each one of these states. And then over here, let's see if I can do this the best I can right sideways. This is COVID deaths, trying to write sideways, per 100,000 people. All right, so that's the best that I can write sideways like that. So we've got our axes labeled. We also want to give this a title. So what we're going to call is we're just going to call this explanatory versus response variable. So I'm going to shorten it a little bit. I'm going to say population density versus COVID deaths. So we've got our axes labeled. We've got our title. We know that this starts at 0. So one thing that I want to try and keep in mind to make a nice looking scatter plot when I'm making one by hand is I want to try to fill this graph as much as possible. So first I want to look at the population density, people per square mile. So I look over here and I look for my maximum population density, and that's 1,207.8. So I'm going to come down here and count how many spots I have on the x-axis. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So what I'm going to do just to make this a little bit easier, I've got 26 spots. My maximum is 1,207. I'm going to make each point on the axis 50 units. So here I've got 100, 200, 300. And what I'm actually going to do, instead of labeling every 100, I'm just going to label every 500 because I don't have much space on this page. So right here we've got 100, 200, 300, 400. So right here, this would be 500, 600, 700, 800, 900, 1,000. And then we've got 1,100, 1,200, 1,300. So we've got our x-axis pretty well sorted. So now we want to look at our y-axis. So I want to find my maximum value for COVID deaths per 100,000 people. And when I look over here, it looks like it is 179. So again, I want to count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23, so what I'm going to do is I'm just going to make each one 10. You can make this filled out a little bit better, but really the reason we're doing this is just to make a nice looking graph. If we make it 10, we're still going to have enough space to fill this out. So I've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. All right, so now to make our scatter plot, remember this is my X coordinate, this is my Y coordinate. So I'm just gonna start plotting points as X comma Y. So the first one is 176.445. So I've got 50, 100, 150, 176 somewhere in here, 45. So we'll just say it's somewhere in this area right here. And we're not going to go through plotting all the points. You guys, I'm sure, know how to plot points. But in order to make the scatter plot, we plot all of our points, and it gives us an idea of the general trend in the data. So when you do that, you're going to end up, and I'll go ahead and skip to what it's going to look like. It's going to look something like this. So this I created using the graphing calculator. So what we're going to do now is we're going to walk through how to do this with a graphing calculator. So first, what you want to do is you want to turn on your calculator and press Stat Edit and bring up these lists. So anytime that we're dealing with lists of data, these lists are what we're going to use. So we're going to clear anything that's in there, and we're going to start entering our data. So make sure that when you enter this data, what you enter here corresponds to your first entry in the second column. We're going to use these as data points. So I'm just going to start entering my data. I've got 375.9, 419.3, and so on and so forth. So while I'm doing this, if you have your graphing calculator with you, please be following along and entering this data as well, so that you are able to walk through these steps as we're doing it. 866.6, 1010.8. And that's also why I'm doing this with you instead of just entering the data. And before I start the video, I'm doing this with you so that you have time to work this with me while we're going through the video. So we've got 45, 29, and this is where it's really important. Make sure you pay attention and that these are lining up, these values are lining up with the X or with the explanatory variable. So 45 is for Georgia, that's 176.4. And as long as you keep things in line, you shouldn't have a problem. One thing you might want to look out for is when you get to the end of your list, if you missed a number, then you'll see that you have a different number of entries in each table. And actually, when you try to make a scatter plot of it, it will give you an error. So just make sure we have 13 entries in both rows. And now we have all of our data entered into a list. So we went to Stat, Edit, enter one variable in list 1, the other variable in list 2. So now what we're going to do is we're going to quit out of this screen. You don't have to quit, but we're going to do that just so that we know how to quit out of the screen. So you press second, Y equals, and it opens up this screen with stat plots. Notice I already have this one on, so I'm going to turn it off. So when you get to this screen, this is what it'll look like. Yours will more than likely all be off. So just pick one of them, and instead of off, change it to on. So press enter to change it to on, and then type. So down here, these are different types of graphs that these can make. So this first one, and I'll unhighlight it for a second. So what this will look like is it's a scatter plot with just, so you can see just the points. So we've got a scatter plot, we've got a line graph. This is a histogram. This is a box plot that shows outliers. This is a box plot that does not show outliers. And then this, I believe, is another line graph. So make sure that you've chosen the scatter plot. So that's highlighted in black. Your X list is whichever list you put your X variable into, which for us was L1. Your Y list was L2. The mark, you can make it whatever you want. I've got is that this little square thing because I think that's the easiest one to see. So once you have all of this set up, what we're going to do is we're going to quit out of the screen and we're going to press zoom. And then down here, number 9 says zoom stats. We're going to press zoom 9. And oops, sorry, I already have the regression line in there. Hold on. So if you press zoom 9, it'll make the graph with the scatter plot and it'll give you the best window for the scatter plot. So this is what this is going to look like. So when we look at our scatter plot, one thing that we want to think about is, what do we notice about this? And in general, what we tend to see here as the population density increases, so too does the COVID deaths per 100,000 people tend to increase. So that relationship is called a correlation. So if there seems to be some kind of linear relationship, well, if there seems to be some kind of relationship between the explanatory and response variable, then we say that they're correlated. So what correlation means is when two variables have a distinct, roughly linear pattern, and linear means line-like. So there are a couple types of correlations. We have a positive correlation, and a positive correlation happens when the response variable increases when the values of the explanatory value also increase. And it looks like a line with a positive slope. A negative correlation is when the values of the response variable tend to decrease when the explanatory variable increases. And that looks like a line with a negative slope. So, and like I mentioned down here, for our purposes, the correlation that we're going to analyze is linear correlation. There are a couple different types of relationships that could happen, and I'm going to show you what those look like, but we're going to be analyzing linear correlation between variables. So that is it for today's video. We talked about creating scatter plots. We did them by hand and then also with a calculator, and then we gave a definition of correlation. So in class, we're actually going to take this scatter plot and analyze it a little bit more, and then I'm going to let you guys have a chance to collect some data and make your own scatter plots and tell me what conclusions you can draw from them. But I hope that you took some notes. Any questions that you have, make sure that you bring them to class, and I hope you have a great day.